Hello, guys. Once again, you're welcome to this episode of AWS Security Services Explained. So thank you once again for joining me. So on this episode, I want to talk about AWS Key Management Service, the service we call KMS. Now, KMS, what does it do? Like the name implies, Key Management Service. It's, it's managed service that that allows you to, manage keys and encryption mechanism. So let me say this here. KMS is a managed service that makes it easy for you to create and manage keys and control the use of encryption across a wide range of AWS services. KMS is a secure and resilient service that uses FIP 1403 validated hardware security modules to isolate and protect your keys. Okay, now if you look at AWS, KMS within the console, you will see that we have KMS. We have under the KMS we have AWS managed keys and we have customer managed keys, and we have the stores as well. We have external key stores and we have AWS Cloud HMS key stores. Now let me break this down. It means that the storage where keys are stored can be something that you can use what AWS provided you, or you can bring your own key store, maybe like HashiCorp Vault. Then that is the storage. Now when it comes to the key itself, that shows that you can have your own key managed within AWS environment. At the same time, you can hand over your key management to AWS. So it depends on your architectural decisions, trade-offs, and stuff like that. Now, the other thing I want to say is that, so why do we need key management? Now, in the world of technology, one of the things we protect is what I call a confidentiality of data confidentiality. The other thing is data identity or integrity. Then the third one is, authenticity, So these are the three pillars of what we call a public key infrastructure, PKI. And that is implemented, through some of the services within AWS. And one of them is KMS. So KMS, when you are creating a KMS key, you are creating a key that will help you to either keep the confidentiality of your data, or to, prove the identity of your data or the ownership. Or the other thing is that to say, okay, this data is what it says it is, or what this data is, we can say is authentic, it can be valid, is secured, it can be validated. Okay, this is the real data. So these are the three pillars, and I want to explain, try to do some justice to this. So when you talk about the first pillar, which is encryption, it means like hiding the data. You are hiding the data so that it will not be on the plain view. Then the other one is identity integrity. You are proving that the author is the right author, or maybe the right person that have access to it. Then the authenticity is you trusting, saying that, okay, the system is saying, oh, we can trust this channel of communication with this data and stuff like that. So this is what we call AWS Key Management Service, KMS. So now moving forward, I want to say something here that that are very important when it comes to KMS. Now, if you look at some of the capabilities of KMS, it's what people will tell you that it FIPS 140-3 level 3 HMS, compliant. Now, this is let me break it down. So in a real world, what this thing is saying is that when you have a card, when you want to use KMS key, KMS is not stored or maybe downloaded or stored on your laptop. It cannot be done. KMS is stored in a hardware, in a military grade hardware within AWS data center. And that is why it is called the Titanium Vault. So it's a high grade, high quality, well secured military grade hardware. So, and one other thing you have to note is that when you create a key in KMS, AWS does not save it as a test file on a standard hard drive. They store it on this military grade, computer called hardware security module, and it's within their data center. If you want to de-encrypt the file, you cannot download the key to your laptop to do the math. Instead, you send your encrypted file into HSM. The HSM decrypts it inside its secure hardware chips and hand you back the clean data. That is to tell you. So the reason why I read that for you is that is to tell you that when you KMS a file and you want to de-encrypt it, you don't download and de-encrypt it. No. The operation of the encryption is taken off the local machine, or maybe some commodity machine, server machine within AWS environment, and even your local laptop, and done in this Titanium Vault, in a military grade computer, so that at the end of the day, even if somebody have access to your AWS environment and kind of hijack your AWS environment, it will become very difficult for them to have access to your key that encrypt your data. So the benefit is the benefit I've just said, that even if an attacker somehow gets root access to AWS cloud infrastructure, they cannot copy or steal your master key materials. It physically cannot be exported from the chip, cannot. So the other thing I want to say about KMS now that I've talked about the hardware security module, the next thing I want to talk about is the encryption, the envelope encryption. Now, in a real-world environment, cryptography has a speed problem. Now, asymmetric master key like RSA are highly secure but mathematically slow. That is one thing we know about encryption. Encrypted data is very slow. Now, if you try to encrypt like 10 GB database using a master key directly, your application will grind to heart. So what do you do? So this is how KMS works in terms of encryption. KMS doesn't just encrypt, using that RSA key like that, asymmetric key like that. No. What it does is that it uses what we call data encryption key deck, to encrypt. Is a lightweight encryption math algorithm that it's a lightweight. That shows that speed is not a problem in this particular context. So it uses that deck, lightweight algorithm to encrypt that 10 GB database, and now use RSA asymmetric key to now encrypt the deck itself. So if you look at it, if you understand what I'm saying now, is that you use deck to encrypt the larger data. Then the encryption key for that deck is small. You use RSA asymmetric math to encrypt that key. So that is a kind of level, like layered security. But what you achieved is that you are able to encrypt a large volume of data with a particular algorithm that will not slow down your data speed, and then you now use a more secured algorithm to lock the key. So you use another key to lock the key. So this is another thing you have to you should understand about the internal workings of encryption of KMS. So the other thing I wanted to know is the annual key rotation. So KMS rotates there are a lot of maybe PSA DSS requirement that says that every key should be rotated every year. So it does that for you. But the catch there is that you have to know that if you encrypted the data 3 years ago and now maybe last year, and now you are changing the key, the system is changing the key, it doesn't recreate the data and encrypt it with a new key. No. What it does is that the new data generating moving forward will be encrypted with a new key. So that shows that there is a way that AWS keep the old key in a key ring to make sure that if there is a request for old data that was encrypted with old key, there's a place where you can pull it out and use that to do that. So the last one here is what is called dual layer access control, the military lab. Now here, if you look at the creation of keys, like a key within AWS environment, you see that for the fact that you are the key administrator doesn't mean that you can use the key. So there is a key manager and there is a key user. So when you are defining your key, the key user is the person that is allowed to use that key. So for the fact that you created a key doesn't mean that maybe if you can use that key. So that is to tell you that an IAM user account have permission to talk to KMS. You understand me now? The user it doesn't matter that maybe you're an IAM user, you have the right permission to talk. No. You have to be specifically given within the creation of that particular key that, okay, you are the user here. And if you look at the benefit, let me give you an example. An IAM administrator usually has the power to see and modify almost everything in an account. This creates a massive security risk. A rogue IAM admin could read all the sensitive data keys. AWS solved this by giving KMS keys in their KMS keys their own independent security guard. So that is that. A security benefit is that if the key policy does not explicitly say a root account or an IAM admin can use this key, then even the absolute administrator of AWS account is completely locked out. That is what I was trying to explain. That even if you are the root admin or root user, if you are not explicitly giving access to use that key, you cannot do that. So this is what KMS is all about, and these are the major point that I want to bring to us. And if you look at what I've said, you see that what are the business problems that this particular service kind of solve for us. Number one is key management lifecycle sprawl. That shows that if there is a way we can cut over to a new key, that shows that we don't need to manually think of, oh, maybe that key is expired, or maybe that certificate is expired, or whatever. So compliance, separation of duty. If you look at the fact that even if you are an AWS admin user, that does not mean you have access to to use some keys. So cross-account encryption, data sharing, sharing encrypted data with partner account. So that's why a key policy can be granted across multiple AWS account. So these are the business problems that these kind of solve. So that is the end. That is what I have to say. What I have to bring to you in the case of KMS right now, and I believe that this will help a lot of people. Once again, my name is John Kayode Abisi, and I will stop this here and I'll move forward.